Welcome back to Unit 1, Forces and Motion. Our second section is called Acceleration. The important terms in this section will be velocity and acceleration. The unit for acceleration is meters per second squared. On your notes, which shall begin on page 52 of your notebook, please title the question at the tippy top, then title the section Acceleration. We will have our vocabulary terms, the formula for acceleration, and then acceleration formula practice at the bottom. Okay, so our question is, what is the difference between positive and negative acceleration? Then go ahead and title this section 2, Acceleration. Our first term is the term velocity. Now, velocity includes both speed and direction. So this is the speed and direction of an object's motion. So speed is just how fast something is going, and velocity is how fast and which way. Kind of like how distance is just how far the object has gone, but displacement is how far in what direction, so how far from the starting position. So velocity goes with displacement, speed goes with distance, or excuse me, speed goes with distance. The equation for velocity that you want to write down is velocity equals d over t, except that here you probably want to note that this d actually is displacement, but t is still time. So we're just talking about displacement over time instead of distance over time. So here I want you to write down this question. What is the difference between speed and velocity? Well, the difference between speed and velocity is that velocity is both speed and direction. It tells you how fast and which way. Now, acceleration is the rate of change of velocity, and there's actually 3 types of acceleration, and I want you to write down those 3 types, and then this is a picture representing each of the 3 types of acceleration. So the first one is speeding up, next slowing down, and then last changing direction. Let me even make this really, really big so that you can see the details. Okay, so the first one here, this is representing speeding up, so we've got the little lines showing that he's going faster and faster. So I'm accelerating because I'm speeding up. Then the next one is I'm accelerating because I'm slowing down, so he has speed lines here and they get smaller and smaller and he comes to a stop. So I'm accelerating because I'm slowing down. So that's a change in speed for both of these. Now remember that velocity includes direction. So if you're changing direction, that's also a change in velocity. So here's this bee that's probably going around at the same speed, but going up and down, then going in this big loop, accelerating because changing direction. So these are considered accelerations, and they always have to involve some kind of a force. Acceleration doesn't happen randomly. Remember that an object will go at a constant velocity, or an object in motion stays in motion till an outside force acts on it, or an object at rest stays at rest till an outside force acts on it. So here you've got your feet causing you to run faster. Here, friction between the wheels and the ground is going to cause the skateboarder to slow down. And here, the wings of the bee are going to push on the air in order to cause the bee to change direction. So anytime something is accelerating, that's because some force is acting on the object to make that acceleration happen. Now here's the formula for acceleration. And this formula has some odd little symbols. Now this triangle here, when I have A, that's acceleration, is equal to triangle V divided by triangle T. This triangle here is a Greek letter. It's the Greek letter delta. So alpha, beta, delta, gamma, blah, 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 blah. The delta actually in math refers to change in. So the change in velocity divided by the change in time. And so I've rewritten it here, and if this is kind of confusing for you, you can just do this. And this is VF minus VI over time. So VF stands for final velocity, so your ending velocity. And then VI stands for your starting velocity. So this is kind of like when you do the slope of a line and you have your y2 minus your y1, so your second minus your first, or your end minus your start. That's what that's referring to. And down here, usually we consider the starting time 0, so that's why there's no TF minus TI. Technically there should be, but most of the time your starting time is considered 0 anyway. So any number minus 0 would just be that number. So there's that equation for acceleration. The last thing that we're going to do is we're going to actually practice using that equation. So we're going to talk about positive acceleration and negative acceleration. First, here's positive. So we have a plane takes off. It accelerates from 0 meters per second to 80 meters per second in 20 seconds. So what this is saying is that the plane is speeding up from rest, or 0 meters per second, and it reaches a top speed, or a final velocity, of 80 meters per second, and that happens in a time of 20 seconds. So how I would calculate the acceleration here is I would take my final velocity minus my initial velocity and then divide that by the time. So my final velocity that I ended at was 80 meters per second, so I put 80 here. And then my initial velocity was 0, from 0, so that's my starting velocity, so 0. And then the time was 20 seconds. So 80 minus 0 divided by 20, 80 over 20, 4. So that's 4 meters per second divided by seconds. So that's what I'm saying. That's 80 divided by 20 gets us 4, and the units are meters per second divided by seconds. So I can either write meters per second, so that would be m/s/s again, or I can write it this way, meters per second squared. So what that is saying is that every 1 second you're going faster by 4 meters per second. So you have a speed divided by a time. So that's where the squared s comes from. So in this case, we have the plane is speeding up, so it has a positive acceleration. So please make sure that you write down that this is positive acceleration. So write down what the statement of the problem is. Write down the formula. Please write this formula down with the letters. We want to copy this down to make sure that we're using the formula correctly. One common thing that I see is people doing this backwards. Well, they'll have the start minus the end because they just think about things chronologically. But you want to think about the end minus the start because that's the change. It's the second minus the first. So like if I was talking about my age from when I started high school to when I ended high school, like what was my change in age, I wouldn't say, well, I started at 14 and I ended at 18, so my change was 14 minus 18. That would be -4. When I think about a change, I do the big number minus the little number, so that's 18 minus 14, which is 4. So that is my positive acceleration here, showing speeding up. Second, let's look at the negative side. So a bike comes to a stop from 3 meters per second in 2 seconds. So a bike comes to a stop. So this is slowing down to a stop. So we have the final velocity minus the initial velocity over time again. Here, the final velocity is 0 because it comes to a stop. That means that it was in motion and then it comes to a stop. It comes to a velocity of 0. Minus, excuse me, my starting velocity, which was 3 meters per second. So 0 minus 3 over the time of 2 seconds, over 2.
So here, instead of it being the big number minus the little number, it's the little number minus the big number, because this is a slowing down situation. So we have that the acceleration is going to be -3 divided by 2, which is -1.5 meters per second divided by seconds, because the units are meters per second on the top and seconds on the bottom. Meters per second on the top, seconds on the bottom. And that gets us meters per second, or meters per second squared. So the bike is slowing down, so it has a negative acceleration. So the difference between positive and negative acceleration is that positive acceleration means speeding up, negative acceleration means slowing down. And I don't have a mathematical example for you for changing direction, so we're not going to worry about that just yet. We just want to worry about positive and negative acceleration. Positive is the speeding up. Negative is slowing down. So if you have an acceleration that's negative, that tells you that something is being slowed down. If the bike is coming to a stop, it's probably either from the friction on the ground or the brakes on the bike. And then here, where the plane is speeding up, that comes from the engine of the airplane pushing it forward and the wheels pushing against the ground to make it go forward. So a force is causing it to speed up here, a force is causing it to slow down here. Now our quick summary: velocity is both speed and direction. Acceleration is the rate of change of velocity over time, which can be speeding up, slowing down, or changing direction. So positive acceleration is speeding up, negative acceleration is slowing down, changing direction is the third type of acceleration. And there you go, all done.